Assalamu alaikum. In our first lesson, we have studied about the type of mixtures and their properties. Now we will study the second lesson. The name of the lesson is the solution process. Let us have a look on the objective of the lessons. List and explain three factors that affect the rate at which a solid solute dissolves in a liquid solvent. Second, explain solution equilibrium and distinguish among saturated, unsaturated, and supersaturated solution. Explain the meaning of like dissolve like in terms of polar and non-polar substances. Effect of temperature and pressure on solubility. So these are the objectives that we will try to cover in this lesson. The most important thing, please, once you will get the idea of the lesson, we would like that you will make your own summary of the lesson and send us as PowerPoint presentation. So let us start with our first topic of this lesson, factor affecting the rate of dissolution or dissolving. Dissolution means dissolving. Now, before I will start this topic, all of you remember that a solution, it has two components. One is solute and one is solvent. Solute, in a solution, a substance which dissolve in a solvent, that is called solute, and solvent, in a solution, a substance in which solute is dissolved, that is called a solvent. I give you the same example. If you're dissolving sugar in water, sugar is solute and water is a solvent. Now, what are the factors on which dissolving depends? What are the factors that affect the dissolving, that affect the dissolution? The first factor we have here is surface area of the solute. The second factor we have stirring or shaking, which is also known as agitating. And the third factor we have, that is temperature. Now, first of all, surface area. As the surface area of the solute will increase, the dissolving process will speed up. Now, for example, for the first point here, let us discuss one example. If you have 5 grams of sugar in crystal form and 5 grams of sugar in powder form, which one has more surface area? Of course, the one which is in powder form, it has more surface area, the one which is in crystal form. And if you dissolve both of them, the one which is in powder form will dissolve more speedily as compared to the crystal form. So this is the first factor. The first factor, that the surface area of solute, if you increase it, the dissolving process will increase. Second, stirring or shaking. Before I will explain you the process of stirring or shaking, remember one thing: when solute particles, they are more colliding with the solvent particles, the substance, the solute will dissolve more quickly as compared to if it is we are not shaking or dissolving. Now, stirring or shaking, whenever you are stirring, you are shaking solute in a solvent. Of course, with the shaking or stirring, the solute particles, they are in much contact. The contact of the solute particles increases with the solvent, and this speed up the dissolving process. The third one, we have temperature. Now, if you get the idea of stirring or shaking, it is very easy to understand the effect of temperature in dissolving. Whenever you are heating a solution, of course, a solution, it contains solute and solvent. Both particles of solute and solvent, they will speed up, they will collide, they will collide frequently with higher energy. And as a result, when the solute particles, they're colliding with the solvent particles, the dissolving process will increase, will speed up. So these are the three main factors which increase the rate of dissolution, or which increase the rate of dissolving. This is the first topic. Let us move to the next one. What is solubility? Before we will cover this topic, we should know the definition of solubility. We should know the definition of solubility. What is solubility? We can define it as, if you want to write with me also, you can write the ability of one substance to dissolve into another substance at a given temperature and pressure. The ability of one substance to dissolve into another substance at a given temperature and pressure, that is called solubility. Of course, if we are dissolving salt in water or we are dissolving sugar in water, there is a limit, there is a limit of extent to which it will, uh, to what it will dissolve. That is called solubility. If you add a spoonful after spoonful of sugar to tea, eventually no more sugar will dissolve. This illustrates the fact that for every combination of solvent with a solid solute at a given temperature, there is a limit to the amount of solid that can be dissolved. The point at which this limit is reached for any solute solvent combination depends on the nature of the solute, the nature of the solvent, and the temperature. To what limit it will dissolve, it depends on three factors. It depends on the nature of the solute, nature of the solvent, and the temperature. So we understood what is solubility. If you look at this diagram we have here, the first diagram is lithium chloride is dissolved in water, and lithium chloride is soluble in water. It will dissolve in water. It will dissolve in water, and we will see a uniform solution here. Lithium chloride is dissolved in water. This is example of a soluble solution. And the second example we have is an insoluble solution in which lithium chloride is insoluble in toluene. Lithium chloride is a solute and toluene is a solvent. When a solute is first added to a solvent, solute molecules leave the solid surface and move about at random in the solvent. As more solute is added, more collisions occur between dissolved solute particles. Some of the solute molecules return to the crystal. When maximum solubility is reached, molecules are returning to the solid form at the same rate at which they are going into solution. So remember one thing, this actually defines the solution equilibrium. Solution equilibrium is the physical state in which the opposing processes of dissolution and crystallization of a solute occur at the same rate. Now let us move to an important topic, the types of solution on the basis of solubility. This topic, guys, is very important, and you need to solve a worksheet also related to this topic as well. Types of solutions on the basis of solubility. On the basis of solubility, we have three types of solution. One is known as saturated solution. The second one is known as unsaturated solution. And the third one we have that is known as supersaturated solution. Now, what is the difference between these three types of solutions? First, we will start with the saturated solution. Saturated solution, a solution that contains the maximum amount of dissolved solute, is described as a saturated solution. For example, I will say that we have 10 ml of water. We have 10 ml of water, and the maximum amount of salt which can dissolve in this 10 ml, I will say, is 7 gram. Now, if you dissolve 7 gram in 10 ml of water, the maximum amount is dissolved. It means that this type is saturated solution. If you dissolve more than 7 in it, it will not be saturated. Then the amount you're adding more than 7, that will become insoluble. Now, we understood that amount we get at the bottom, and that will be insoluble in the, so maximum amount which is dissolved, that is known as saturated solution. Now, I said again, what is unsaturated solution? We studied the maximum amount is the saturated. Now, less than the maximum, whatever the amount dissolved in a solvent, that is known as unsaturated solution. A solution that contains less solute than a saturated solution under the same condition is unsaturated solution. I'm repeating again. Just now we considered one example that maximum we can dissolve is 7 gram of salt in 10 ml of water. Now, if the amount is less than 7, for example, it is 5, it is 6, so that type of solution we can consider unsaturated. But the amount, when the amount will reach to the 7 gram, it means the maximum amount is dissolved, that is the saturated. Less than the saturated, that is known as unsaturated. Now let us move. If you look at this diagram also, now this diagram is explaining about mass of solute added versus mass of solute dissolved. Now if you look at this part, the solubility is mentioned here that 46.4 gram per 100 gram. It means the maximum amount of of NaCH3COO it can dissolve in water. It can dissolve in water is 46 in 100 gram of water is 46.4, and this is the solubility. This is the solubility of this solute in water, 46.4. It means if you look at this graph, before this 46.4, before 46.4, this one is unsaturated. Whatever the amount from 0 to 46.4, this one is an example of unsaturated, and above 46.4, we have an example. This will become saturated solution. Now let us move to the third type, which we have supersaturated solution. Now, as how we will define this one, we can say a solution that can dissolve more solute than the maximum amount by heating and then cool it. Now, guys, this is very important. Now, you reach to the maximum amount, but still, if we add under normal condition, the more solute, the more salt, it will not dissolve, it will appear at the bottom. But if we will heat that solution, we can add more amount of solute. We can dissolve more amount of solute, but once we leave it, that will appear again in the form of crystal. That solution is known as supersaturated solution. That solution is known as supersaturated solution. So these are the three types of solutions on the basis of solubility. There is one worksheet also. You have to read this carefully, the PowerPoint presentation. You have to read the book carefully, and then you have to attempt that worksheet. Now, solubility values, as I told you, that solubility, we take that a certain amount, the maximum amount which can dissolve in given amount of solvent, that is known as solubility. We have already discussed about the solubility. Let us move on to the solute solvent interaction. Now, another important topic, we have solute solvent interaction. Before I will explain you, remember one thing. If I will ask one question, that why alcohol will dissolve in water and why oil will not dissolve in water. There is a very common thing in chemistry we use, in science we use. The reason behind it is like dissolve like. Why alcohol dissolve in water and why oil will not dissolve in water? The reason is like dissolve like, and the meaning of this is polar substance will dissolve in polar substance and non-polar substances will dissolve in non-polar substances. Alcohol is a polar substance, water is a polar substance, both of them they dissolve in each other. Oil is a non-polar substance and water is a polar substance. Oil and water, they will not dissolve in each other. You will find a separate layer for both of them. Now, what makes substances similar? What makes substances similar? We are using the word like, dissolve, like. Now, what makes substances similar? It depends on these factors. It depends on type of bonding. If any substance it's forming ions, like water form ions. If I dissolve salt, the salt will form ions. Like dissolve like, type of bonding. Polarity or non-polarity of molecules, I have already discussed. Intermolecular forces between the solute and solvent. What type of forces are present in solute and what type of forces are present? Intermolecular forces are present in solvent, which London dispersion force, we have London dispersion force, we have hydrogen bonding. All these include in intermolecular forces. Now, what is hydration process? You will read all this thoroughly. I just explain you in simple. The solution process with water as the solvent is referred to as hydration. So we can say any process in which you're forming any solution in which water is a solvent, that process we consider hydration. In hydration, the water molecules gathered around the solute molecules. If you look at this one, we dissolve lithium chloride in water. These are the molecules of lithium chloride, and these are the molecules of water. So water molecules, they surrounded the lithium chloride crystal, and this is known as the water molecules. They're surrounding here Cl negative ion, and here they are surrounding the Li plus ion. This process is known as hydration. Even the meaning of go through over the immiscible and miscible liquids. Liquids we divide into two types: miscible liquids and immiscible liquids. Now, what is the meaning of miscible liquid? Miscible liquids, the liquids that are completely soluble with each other. Immiscible liquid, the liquids that are not soluble in each other. Example which are soluble in each other: alcohol and water. Immiscible, I gave you the example already, the water and oil, they are immiscible liquids. Next topic, we have effect of pressure on solubility. Now, the effect of pressure is mostly we will see in case of gases as compared to liquid and solid. Now, increasing the pressure of the solute gas above the solution causes gas particles to collide with the liquid surface more often. This causes more gas particles to dissolve in the liquid. If you increase the pressure of the gas, of the solute gas, it will collide more frequently, more oftenly with the solvent molecules. As a result, the solubility will increase, and the vice versa. And next we have is Henry's law also explained the same thing, that the solubility of the gas solute will increase in the solvent by increasing the pressure. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of that gas on the surface of the liquid. This is very important, guys. Look at here. In carbonated beverages, the solubility of carbon dioxide is increased by increasing the pressure. In all carbonated beverages and all soft drink which has a gas, carbon dioxide gas, the solubility of carbon dioxide gas is increased by increasing the pressure. The sealed containers contain CO2 at high pressure, which keeps the CO2 dissolved in the beverage above the liquid. The rapid escape of a gas from a liquid in which it is dissolved is known as effervescence.